Okay, so we're going to talk specifically today about friction. Okay, so there's a couple of things you need to know about friction. It's a force, so if we want to calculate friction, it's still F equals ma. So it's really no different than that, but there is a few more things that we need to talk about when it comes to friction. Some concepts, okay, that are quite important. And I'm going to really briefly talk about those concepts. One is it's always going to be opposite of motion. So when you identify which way something is moving, friction is always going to be the opposite direction. So if it's moving north, friction will be pointing south. If it's moving northeast, friction will be pointing southwest. Okay? Always opposite. We can express friction through something called mu, which is a coefficient, which is basically the amount of friction over what's called the normal force. Now, you may have remembered from optics, the norm is something that's perpendicular to a surface. So if you pick a surface, imagine this wall is the surface, the normal force would be perpendicular to that surface. Okay? If the surface was this way, the normal force will probably be pointing up, because obviously gravity will be pointing down. So always going to be perpendicular to the surface. And mu is just an expression of the amount of friction relative to that force at the surface. The higher mu is, the more friction there is. The lower mu is, the less friction there is. So when it's like on a road, and the road has really good conditions, like it's dry, you can expect mu, which is like the coefficient of friction in your tires, to be really, really high. Probably close to 1. And that's good, because the higher the coefficient of friction is, that means the more friction there is to stop you when you have to slam on your brakes. When it starts to get cold, or it starts to snow, or there's ice on the ground, what do you think happens to that coefficient? It goes down significantly. And that's why people slide. Okay? Now, there's two types of friction. The one that we still use the exact same equations to analyze them. There's still F equals ma. It's still mu equals Ff over Fn. But the two types of friction that we talk about is static friction or kinetic friction. Static friction is the amount of friction that you have to overcome to start moving something. The static means not moving. And then kinetic friction means the amount of friction required to keep something moving. Yeah, and as you saw in the little activity, at least what you should have seen, is because of Newton's first law, it should take a little bit more energy, or more force, to overcome static friction. So static friction should be a little bit higher than kinetic friction. It should take more to overcome that than to keep something moving, because of Newton's principle of inertia. Okay, so so Rapti, let's use your data, because what did you get more of the force of static friction in your experiment? So the subscript, if you ever see this little subscript, so this is the symbol mu, it's a Greek symbol. Mu is that coefficient of friction. If you see a little s beside it, that means static friction. If you see a little k beside it, that's kinetic friction. Okay, but the equations are still the same. Just a reminder: there's two different types of friction. One for things not moving, and another for things that are moving. Your static friction was about what? 6 newtons. Your mu k was about 4. You said. And what was the weight of your object? 1.8. So if I said to you, so if your weight was 1.8 newtons, now that object that you have, $17 newtons? Sorry. Okay. Okay, so we'll just say your weight was about 18 newtons. So you used a bag, right? Like just a regular school bag, resting on a surface. So the weight is 18 newtons. what do you think then the normal force would be? Right, it should be the same. Because if it's 18 newtons down and it's on a surface, that means it's 18 newtons up. So if I said to you, what's the coefficient of friction for mu s, you would say it would be 6 over 18. And if I said to you, what's the coefficient of friction for mu k, it would be 4 over 18. So what is 6 over 18 is like 0.33, and 4 over 18 is, what is that exactly? 0.2 something? 0.2? Yes. Right. Yeah. So the formula for mu is just the amount of force required to get something to move over the amount of force, which is the normal force. So there's your Fn right here. And this is the amount of force you have to overcome. So the formula is still Ff over Fn. So what I want to do is I want to look at a few simple calculations with friction. Okay? And you'll notice that it's not much different than what we've been doing. So here's the first question. Okay? A box, a 100 kilogram box, sliding across the surface. The box travels 10 meters in 10 seconds. So it's sliding, we'll say it comes to a stop, and we want to know what's the force of friction. Alright. We know the equation for force is what? F equals ma. Can we get acceleration from the information provided here? Yeah. Because we have a distance, and we have a time. Correct? And we could figure out acceleration. If you remember the equation, when you don't have a speed, you could use this equation, half at squared. We could rearrange that to get a. A is 2d over t squared. So whenever you have a question like this where you have an object that is traveling at a speed, right, and slows down to 0, and we have the distance at the time, you could use that equation. But you're like, no, we can't because we don't have initial speed. Yes, you can, because if you watch that in reverse, it's the same answer. Having an object start at a speed and slowing down to 0 over a distance of 10 meters in 10 seconds is exactly the same as starting off with a speed of 0 and accelerating it over 10 meters for 10 seconds to some unknown speed. It's exactly the same. It's just the opposite way, right? So what we can do is we could solve for A. What would you get for A in this case? So A would be what? 2 times 10 over 10 squared. Let's finish it over here. A would be what? 0.2 meters per second squared. Now, what is that acceleration due to? What is that? That's the acceleration due to what? But what's stopping it? Friction. So this actually, if we had to think about labels, this is the acceleration due to friction, because what are we looking for? The force due to friction. So this actually is the acceleration due to friction. So I'm going to label it as AF. And you're right, it's pointing the opposite way of motion. Because the definition of friction is, it's always, because what else would stop it? We have to assume it's friction. Okay, so then what's the force of friction? Well, now the force of friction is the mass times AF. So the force of friction would be 100 kilograms times 0.2, which is 20 newtons. That's the force of friction. So So far, is anything different? No, right? It's still F equals MA. But today we introduced the concept of mu. So mu is FF over Fn. We have to assume that we have a box. We have to assume that the box has a weight. And we have to assume that the normal force in this case is the exact same as the weight. Now, listen carefully. If you push down in the box, it's not the same anymore. Or if you pull up in the box, it's not the same anymore. Because if you push down or up, you're introducing another force vertically. But if we're not pushing up or down, and the box is on a surface, then the downwards force has to be the same as the upwards force. So, in other words, the Fn has to be the same as the weight. So in this case, we know the force of friction is 20 newtons. What would the weight be of that box? It would be 100 times what? Times 9.8. So remember the weight is mg. Okay, so what's the coefficient of friction? It would be very close to 20 over 1,000. So your answer, if you allow me to round up, should be very close to 0.02. Okay? It's not? It's like 0.019 something, right? But that's okay. Okay. So what is new is this formula for coefficient. That's the only thing new that we've introduced. So let's use it in the next question, where we have mu. So we have tires that have a coefficient of friction with a particular surface, and the coefficient is 0.8, and we want to know, well, so in other words, we're going to do the opposite question, basically. How far does a car travel from a speed of 20 meters per second? Okay? So we're going to answer basically questions almost the reverse of the other question. So let's think about this car. Now, are you upset that I didn't give you the mass of the car? So some things in physics you may think that you don't have enough information because either your teacher screwed up, and if it's me, there's a good chance it screwed up, or maybe you don't need it. So let's see if we don't need it. So we have a car on the road, and we know what the car has a weight. And if we're assuming that the car does not have any other vertical forces acting on it, then the weight has to be the same as what? Normal force. Coefficient of friction is mu equals FF over Fn, right? So the normal force is the same as the weight, so wouldn't it be FF over Fg? Because Fn and Fg are the same. If I rearrange this, actually before I rearrange it, I'm going to ask you, do you agree with this? Because any force is F equals ma, right? So wouldn't the force of friction be the mass of the car times the acceleration due to friction? Because F equals ma. And the weight is the mass of the car times g. So if there are no other forces vertically, then mu is just simply acceleration of friction over g. Right. But this is under two conditions. Okay? One, no other, I'm going to say Fy, which means vertical forces. And two, if the scenario is perfectly horizontal. If it's vertical, which is the next situation, it's totally different. Okay? We're going to assume it's perfectly horizontal. We're going to assume this car does not have any spoilers or ground effects that change the up and down force. So then m cancels out, right? And if I said to you, how do you get the acceleration due to friction? What would you do? You would just say, well, AF has to be mu times g. So the acceleration due to friction then would be mu, which is 0.8, times g, which is 9.8. So what is that, like 7.9 something? 7, Rapti, what is it? You're pretty quick with that calculator. 7.84? Okay, 7.8 meters per second squared. That's the acceleration due to friction, right? Can we now figure out the distance? Okay, so we could use the good old-fashioned d equals vit plus 1/2 8. Oh, wait a minute, we don't have the time. We don't want to use that equation. What we could use that equation. Maybe this equation will be better. You could use this equation, but then you got to find time. Let's use that one. Bf squared equals vi squared plus 2ad. And let's solve for d. So if I rearrange that, you're going to get vf squared minus vi squared over 2a is your distance. So let's finish it off over here. Distance. Okay, what's your final speed? What's vf? So 0 minus what's your initial speed? 20 over 2 times your acceleration. Now, let's be accurate here. The acceleration, should that be negative or positive? Why? Yeah, so if we take the initial speed as positive, and something is slowing down, that means the acceleration has to be pointing the other way. So this is going to be negative 7.8. So distance should be 20 squared, which is about 400 over about 16. What is that? About 25? Close to 25? Miriam? What is it? Huh? 25.6? 25.6. Yeah. It's not the only, like, you could figure out the time, because you have the acceleration, you have your VI, you have your VF, you could find time, and then use V average times time. Or you can use that equation, D equals VRT plus half AC squared. Yeah.
You also have the two conditions you had at the top.
Yeah.
What is the second one?
Which one?
The two conditions for using that equation.
So there can't be any other vertical forces, and it's got to be horizontal. I'm going to show you one really quickly where it's not. That's okay. This won't take long. This question is actually really quick. There's only one calculation question here, and the other one is just a concept. So in this case, we have a box being held up this way. Okay? And you're pushing this way. So, in other words, there's a force going into the wall. Which way would the normal force point? This way. So the Fn would be this way, right? So this would be your applied force, and then your normal force would point the other way. And this has to be the weight, right? This has to be the weight. So if it's not moving, friction must be pointing which way? Because if this box was to slide, which way would it slide? So it means friction has to be pointing this way, right? Okay. Now, is it true that if this thing isn't going to slide, that the friction has to equal the weight? Because Newton's second law, right? If there's a net force, you're going to have what? Acceleration. If the net force is 0, it's either not moving or moving at a constant rate. So we know then that this has to equal this. Okay. How do you get FF? Well, FF is mu Fn, correct? That's the definition of friction. Coefficient times normal force. So now if we substitute, we have mu Fn equals Fg. Now, do we have mu in this question? It says the box has a mass of 1 kilogram, and it says that the coefficient of friction is 0.3. It's mu. So we could rearrange and say Fn equals Fg over mu, right? Normal force is equal to the weight over mu. The weight is mg over mu. So what's 1 times 9.8? That's 9.8 over 0.3. So that means Fn has to be what? It's going to be close to 30.
I don't know. Wait, so is that FU, Fn equals FG?
So Fn. So here's, we have, just give me like one more minute, okay? Mu is Fn. So this is force of friction equals the weight, correct? The force of friction is mu Fn, right? So mu Fn equals the weight. All I did was rearrange this equation to get Fn.
And then FG is just
Fg is your weight over mu. So what do you get for Fn? 32 points. It's going to round up to 33. So if you apply a force of 33 newtons against the wall, the force of friction should be the same as the weight. If the object isn't moving and the net force is 0, then it won't move. Now the last few questions, just concepts, okay? If the object was already sliding and you apply that force, what should happen? So if the box is already sliding and you apply a force, so it's already moving down, and you apply a force of 33 newtons, the frictional force will be the same as the weight. So the net force then would be what? 0. And if it's already moving, then Newton's first law says it should be what? Moving at a constant rate. Remember, if it's already moving, net force is 0, moving at a constant rate. The last concept, and you guys can have a great weekend, is what would happen if you apply a force that's greater? So imagine that it's not moving, okay? And you apply a force of 1,000 newtons. Your coefficient, so in other words, your frictional force acting this way will be greater than your weight. No, it won't, because would it make sense for friction to accelerate something in the same direction of friction? So in other words, it just wouldn't move. Just wouldn't move, okay? Otherwise it would be accelerating upwards, which is kind of weird. Ladies, have a great weekend. Sorry for that.